Hi, I'm Calais Poirson, and this is Exam 3, Part 1a on the Aqueous Ionic equilibrium section of the test. So today we're going to be finding the pH of a buffer, given the volume and also the masses of the conjugate acid and base, and then we're also going to be finding pKb and molar solubility. So here's our problem. It's a rank from largest to smallest, so there's 3 different parts. The first one, I've got a couple equations written out. So we want to find the pH. We're given volume 150, we're given grams of sodium fluoride, and grams of hydrofluoric acid. So what I notice here is that my buffer equation is going to be hydrofluoric acid and F minus. That sodium ion we can totally disregard. It's just a spectator ion because NaF fully dissociates. So this is going to be my buffer equation. Now I'm looking for the pH, so I'm going to use the equation pH equals pKa plus log of concentration of base over concentration of acid. I look up the Ka of hydrofluoric acid, and I get 7.10 times 10 to the negative 4th. So I know what my Ka is. It's just going to be the negative log of that number. So what I'm looking for is the concentration of base and the concentration of acid. So to do that, I'm going to take my masses I have here, and I'm going to convert them into molarity because that's what we're looking for when we're looking for concentration. So 2.06 grams of sodium fluoride. We're going to multiply by the molar mass to get moles in the numerator. So that's going to be 22.99 plus 19.00 grams. And then I'm going to multiply by 150 milliliters because that's our volume, and then 10 to the 3rd milliliters in a liter to get moles over liters in my final answer. So that's going to be 0.327 molar is our concentration of NaF, but because NaF fully dissociates, we can also call that our concentration of F minus, which is what we want to plug in for our base. So that's going to be in our plugged in there in our equation. And then 2.47 grams of hydrofluoric acid. I'm going to multiply that by the molar mass. And then 150 milliliters. 10 to the 3rd milliliters over liters. Okay, so I get 0.823 molar is our concentration of HF. I'm going to plug that in right there. So now I've got all the pieces I need to solve for pH. So I've got pH equals negative log of 7.10 times 10, 7.10, 10 to the negative 4th, plus log of 0.327 molar, because F minus is going to be my base, and then 0.823 molar of hydrofluoric acid, and that's going to give us 2.748. I've got 3 sig figs to the right of that decimal place because I was given 4 sig figs in the volume, but only 3 sig figs in our masses, so the max amount of sig figs I can do is 3. So that's going to be our final answer for number 1. Okay, going on to problem 2, this is a lot quicker. So pKb of formic acid. Obviously, formic acid is an acid, so when I look up the K value for formic acid, it's going to give me a Ka. So we need to find Kb from Ka. So the Ka of formic acid is 1.7 times 10 to the negative 4, and we know that Kw is equal to Ka times Kb. And we know that Kw is also equal to 1.00 times 10 to the negative 14. So we can isolate Kb by dividing that number by Ka and plugging in Ka. So Kb is going to equal 1.00 times 10 to the negative 14th, over 1.7 times 10 to the negative 4th, which gives us Kb is equal to 5.88 times 10 to the negative 11. Now we know that pKb is just the negative log of a Kb value, so we're going to take the negative log of 5.88 times 10 to the negative 11th to find our pKb, which will be 10.23. I have 2 sig figs to the right of that decimal because I have 2 sig figs in my formic acid Ka. All right, now the third part of this problem, we've got the molar solubility of barium fluoride. So if you put barium fluoride into water, it dissociates into barium 2 plus and fluoride 1 minus. We have to balance that equation because we've got 2 fluorides in the barium fluoride and 1 fluoride over here, so we need to add that 2 to this equation. So now I see that we have S and 2S here, and I look up the KSP of barium fluoride. I have 2.45 times 10 to the negative 5th. I know that KSP is equal to the concentration of barium to its coefficient, which here is 1, times the concentration of fluoride to the coefficient, which is 2 here. Now I'm going to substitute in my S and my 2S for these guys. So I get S to the first times 2S to the second, which gives me 4S cubed. Remember that squared applies to the 2 and the S. All right, so now I've got all the pieces I need. 2.45 times 10 to the negative 5th, our KSP, is equal to 4S cubed. And then I just do this solving all in one step on my calculator. So I get S is equal to 0.0183 molar. Notice I've got 3 sig figs there because I have 3 sig figs in my KSP. So now it's asking us, to finish off the problem, it's asking us to rank from largest to smallest. So let's take a look at what our values are. We've got 0.0183, 10.23, and 2.48. So it looks like our ranking is going to be 2 is greater than 1 is greater than 3. And that's it. Thanks for listening.